maybe look like a ship. We'll show you how here at DEF CON 24 in Las Vegas.
Secure Ninja.
I'm here in the DEF CON contest area, and I'm speaking with Clarence Chio. He was a speaker here at DEF CON. How are you today?
I'm great, thank you.
Excellent. Thanks for speaking with us. I understand you've uncovered some vulnerabilities that have to do with machine learning. So tell us a little bit about that.
Sure. So what I talked about yesterday was about adversarial machine learning, in particular adversarial deep learning. Deep learning is something that knowingly or unknowingly we're interacting with on a daily basis, and there are some statistical vulnerabilities that are embedded in such systems that many people don't know about. So what I did was actually to demonstrate that such vulnerabilities do exist and how easy it is to actually exploit these vulnerabilities. And then I released a framework called Deep Pwning that anyone can use and that download online on GitHub that allows people to generate adversarial input into deep learning systems and basically to find out how vulnerable their systems are. From then on, they can improve their systems and fix the bugs that they find.
Excellent. What got you interested in first searching for these vulnerabilities in machine learning?
So I did machine learning in school, and then after I graduated, I went into the security space, and I found out that there's actually some work done in machine learning. There's actually some work done in security and privacy in the machine learning space, but in the security space, there actually isn't that much awareness about machine learning, even though when you walk the floors of RSA and Black Hat, you see lots of companies touting that they use machine learning. So because there are so many use cases of machine learning in critical industries like the medical field or transportation, when you have self-driving cars, there's lots of chances for these systems to be exploited, and the costs of these systems being exploited are high because it's loss of life or some other critical failure that would be not good.
Absolutely. A lot of different industries could suffer from this. So I understand you actually have some videos here that you can show us that will demonstrate exactly what you're talking about.
Yeah, so what I have here is a simple image classification engine. It's made using deep learning, and we see here that there's an image of a dog, and you and I have no problem recognizing this as a dog. But so what we're going to try to do is to feed it through this evaluation script, which actually runs a machine learning model to recognize this image. You can see that for the normal image, it correctly recognizes it as a dog. But then when you pass in something slightly different that looks like this, if you compare the two images, one is actually a little more noisy than the other. But to you and I, we still have no problem recognizing this as a dog. If you run this through the script, though, it tells you that it's a ship. So that's interesting because it's exactly the same model and the same source of image, and it doesn't look like a ship to us. But the differences between the two images, which is actually this. So this is the difference between these two images, and when you add this noise vector into to the original image, it produces the noisy image, and this noisy image is what causes the misclassification. So I released a framework called Deep Pwning that allows you to generate noise vectors that you can add into images, and hopefully more and more people will contribute to this platform and help to generate more and more different adversarial inputs for different kind of machine learning tasks. So people can use this framework to generate adversarial input to arbitrary machine learning frameworks to see how vulnerable their systems are to such attacks.
So like you said, machine learning is everywhere right now. What are some of the real-world applications that this research could be used on?
Okay, so what inspired me to start on this research is some work that's been done by other researchers that showed that you can skew such models to misclassify outputs from medical imaging or medical classification. And I think something that's really interesting now is self-driving cars. So most self-driving cars use some form of deep learning system or machine learning system to recognize objects on the road. So for example, if the object recognition system recognizes that there's a red light, there's a stop sign on the road, then the car will stop. And so this is like your eyes to the system. And what such attacks can do to the system is when you have real-world examples of such adversarial images, these can be fed into the object recognition system on the car itself, and then make the car think that maybe a stop sign is a go light, and then not stop. So such things have potentially dire consequences when you can have loss of life due to the wrong decisions being made by the engine because of misclassification.
So you mentioned you were hoping to get more people involved to kind of progress this research. Where can people go to learn more about your project?
So this project, Deep Pwning, is on GitHub. It's under cchio/deep-pwning. And what I hope to get people involved in is actually to play around with the tool that I've created and then try to find new applications of this research in other fields, because I've applied this to image classification and some like semantic analysis, but there are so many other fields that use machine learning that I'm not an expert in and I know nothing about at all. So if people can actually look at this framework and then try to come up with examples of how you can generate adversarial input to other systems, that'll be great. I feel like a lot of people in the security industry don't actually know that much about machine learning, myself included, but after doing some research in this field, I realized that as this becomes a more and more important part of the industry, we need to start looking at the vulnerabilities in statistical models, because more and more critical systems are going to be using machine learning, and if the security industry doesn't gather the skills needed to evaluate such systems, then we're not going to be able to evaluate them.
Right. Well, we'll definitely put the link to your GitHub in the video description, and hopefully some people will come your way, and hopefully you'll be able to progress this research. Thanks so much for talking with us.
Thank you. Good talking to you too.
Thank you so much for watching. We hope you've enjoyed this episode from DEF CON 24. Do us a favor, leave us a comment below and let us know what you thought of this episode. Also, what other type of content would you like to see from these shows? Let us know if you were at DEF CON as well. We'd love to hear from our fans. If you haven't yet subscribed to SecureNinjaTV, click the red button below and join us so you don't miss a thing. I'm Alicia Webb, and I will see you in the next video. Bye!